Good morning, everybody. Welcome to Tibbetts Physics. I'm Mr. Tibbetts. What is crappinin'? For this video, we're going to go through a velocity versus time analysis. We're going to analyze this graph right here and see what we could find. And what we need to know for this one is that the slope is equal to the acceleration. And then the other thing is that the area under the curve, or under the line, is equal to the distance. And we'll analyze it at each time interval. So let's look at the first time interval from 0 over to 3 seconds. We'll find the slope for each time interval, and then we'll do the distances. So, acceleration. Remember, slope is change in y over change in x. In this case, our change in y is change in velocity, change in x is change in time. So, delta v over delta t. So, our velocities, if we look at the first time interval from 0 to 3, we end up at 6 meters per second. And we start out at 0 meters per second. And again, we're going from 0 seconds to 3 seconds, so 3 minus 0. 6 minus 0 is 6. 3 minus 0 is 3. And it's 3 seconds, sorry. And 6 divided by 3 is 2 meters per second squared. So the slope, again, tells us the acceleration. Okay, let's look at the next time interval. This time, we're going from 3 seconds over to 5 seconds. The velocity here starts out at 6 meters per second and ends up at 6 meters per second. So acceleration, change in velocity over change in time, which is equal to 6 meters per second minus 6 meters per second, all over 5 seconds minus 3 seconds. 6 minus 6 is 0 meters per second over 2 seconds, which gives us 0 divided by 2 is 0 meters per second squared. What that tells us here is that the person is moving, but they're moving at a constant velocity of 6 meters per second. So their speed is not changing. And we'll do the last one in a second. Quick tidbit. Stupid me went to Dunkin' Donuts today and got some coffee, not realizing that it was National Coffee Day, so the line was about 30 minutes long to get a coffee. And then stupid me ordered a large and not a medium, and they're only giving away free medium coffees, so I had to pay full price for this. Alright, back to physics. So last time interval, we're going from 5 seconds all the way to 10 seconds. Our velocity, at 10 is 26 meters per second, and at 5 it's 6 meters per second. So A equals delta V over delta T, which equals 26 meters per second, minus 6 meters per second. Minus 6 meters per second, divided by 10 seconds minus 5 seconds, equals 20 meters per second, all over 5 seconds, which simplifies to 4 meters per second squared. Okay, now the next thing, after we find the accelerations, or before, we can also find the distance traveled by finding the area under the curve. And we'll separate that at each time interval as well. So that's each time the line changes. So we'll go from 0 to 3. That area is a triangle, that shape. And then we'll go from 3 to 5. Now we have a rectangle. And the last one is from 5 over to 10. And we have this weird shape, not quite a rectangle. So what we'll do is we'll draw a line across. So now we have a triangle plus a rectangle. Alright, we'll do that on the side. Okay, orange for the first one, sorry. So, area of a triangle, 1/2 base times height, equals, the base is 3 seconds, the height is 6 meters per second. So 1/2, 3 seconds, times 6 meters per second. 3 times 6 is 18, half of 18 is 9. Area equals 9 meters, which again represents the distance traveled. Okay, let's look at the purple one. We're going from 3 seconds up to 5 seconds. Area, this time we have a rectangle. So just base times height or length times width. From 3 to 5, that's 2 seconds. And the height is also still 6 meters per second. 2 times 6 is 12, so 12 meters. And for the last one in green, we have to do the area of a rectangle plus the area of a triangle. So area of rectangle plus area of triangle. Okay, let's do the rectangle first. We're going from 5 seconds to 10 seconds. So our base, that should be a triangle. So we have base times height plus 1/2 base times height, or length times width. So, rectangle first, again, 5 to 10, so 5 seconds. And the height, it goes up to 6 meters per second still, sorry. Plus 1/2, now we're looking at the triangle. The base is still the same, 5 seconds. Sorry that my 5's and S's look the same. We'll try and work on it in the future. And then the height. The height doesn't go from 0 to 26, it's going from 6 all the way up to 26. So from here to here. So the height is 26 minus 6, which is 20 meters per second. Hopefully I can do this mental math because I don't have the answer written down in front of me. 5 times 6 is 30 meters. 5 times 20 is 100. Half of 20 is 50, so plus 50 meters. And that gives us 80 meters for that distance. And if we want to find the total distance traveled, all we do is add them up. So 9 plus 12 plus 80. 9 and 12 is 21. 80 and 21 is 101. So the total distance is 101 meters. And that's how you analyze a velocity versus time graph. Hopefully, again, you also found that useful. Until next time, see ya!